Outshining thousands of galaxies at once, they represent one of the deepest enigmas in the cosmos. We invite you to explore quasars, the most formidable light sources known to exist in the universe. These celestial objects are positioned at such immense distances that they offer a direct view into the early chronicles of our cosmos, and their extreme nature pushes the very boundaries of our current understanding of physics. So, what exactly are these phenomena, and how can a single, minuscule point in space unleash such an astonishing quantity of energy? This exploration will take you to one of the most remarkable occurrences in the cosmos, where each new piece of information only deepens the puzzle of the universe. Fundamentally, a quasar is an exceptionally bright galactic core, fueled by a supermassive black hole as it actively consumes surrounding matter. This feeding process releases an incredible amount of energy, rivaling the collective output of thousands of entire galaxies. Picture a cosmic blaze so powerful that its glow is visible across billions of light years. This gives you a sense of the sheer scale of a quasar's energy production. Yet the question remains, how are we able to observe something so incredibly far away? The key is that quasars radiate energy across the full electromagnetic spectrum, from radio waves to X-rays, which our most powerful telescopes can detect. The history of how quasars were found is just as captivating as the objects themselves. During the 1960s, astronomers were perplexed by a group of celestial bodies that seemed to defy all known classifications. These were identified as radio sources located at almost inconceivable distances, sparking questions about whether they might even be messages from another galaxy. Eventually, scientists concluded these were quasars, a breakthrough that profoundly reshaped our model of the universe. To distinguish them from typical galaxies, consider that while a galaxy is a collection of billions of individual stars, a quasar is the singular, brilliant display of a black hole consuming matter at a furious pace. It's the difference between a sprawling, quiet city and a single, blindingly intense lighthouse that cuts through the dark. This energy generation is a breathtaking demonstration of physics in action, as matter heats to unimaginable temperatures in a cosmic swirl before being devoured, releasing its energy as light and radiation. Understanding the mechanics of quasars is crucial because the link between them and the supermassive black holes at galactic centers is key to comprehending cosmic evolution. Every time you observe a quasar, you are essentially looking back in time to an epoch when the universe was in its infancy. They serve as windows into the history of how galaxies formed, with each one narrating the life cycle of the colossal black hole that powers it. However, quasars are not all the same. They are a diverse class of objects with unique properties. Some are exceptionally bright in radio frequencies, while others emit most of their energy in the visible light spectrum. This classification is vital for astronomers, as it helps them tailor their studies of these remote celestial bodies and understand what their differences reveal about the cosmos. Furthermore, the influence of quasars extends to the very formation of galaxies. The immense energy they blast into space can directly impact their local environments, potentially triggering or halting the birth of new stars and shaping the development of their host galaxies. In this sense, quasars are not merely passive beacons, but active agents that have helped sculpt the large-scale structure of the universe we see today. The light from these incredibly distant objects has journeyed for billions of years to reach our telescopes, meaning we see them as they existed in the distant past. This provides us with indispensable information about the universe's evolution and its rate of expansion. These ancient bodies hold profound connections to both the history and the ultimate fate of our cosmos, giving us a unique glimpse into its earliest stages. A critical role for quasars occurred during the epoch of reionization, a pivotal period in cosmic history. In this era, the powerful radiation streaming from the first quasars helped to ionize the neutral hydrogen gas that filled space, clearing a path for light to travel freely across the universe. Gaining insight into this process provides a much clearer picture of how the first stars and galaxies came into existence. Detecting and studying quasars is an exceptionally difficult endeavor that relies on highly sophisticated technology. The most powerful telescopes on Earth and in orbit are specifically engineered to capture the incredibly faint light from these remote objects. With every new observation, we move a step closer to solving the most profound mysteries of the universe, and we can only imagine what future discoveries await us. The light from a quasar is not just notable for its brilliance, it is also packed with crucial information. By analyzing the spectrum of this light, scientists can deduce the chemical composition of the early universe and find clues about the nature of dark matter and dark energy. Each photon that reaches us is like a fragment of a message carrying the history of the cosmos itself. Finally, the study of quasars is deeply connected to our understanding of the universe's expansion. Because they are so distant and bright, they serve as cosmic markers that allow us to measure how the universe has grown and changed over eons. As our exploration of quasars continues, we are on the verge of new breakthroughs that could completely redefine our knowledge of the universe. Ultimately, quasars are much more than mere specks of light against the blackness of space. They are luminous signposts that guide our quest for cosmic knowledge, teaching us about the universe's origins, the physics of black holes, and the intricate evolution of galaxies. Delving into their fascinating world is part of our unending journey to comprehend the vast and mysterious cosmos we call home. Have you ever gazed at the night sky and been struck by a sense of your own smallness in the face of its infinite expanse? Within that immense ocean of stars, there exist objects that burn with an almost unimaginable intensity. Quasars. They are the brilliant, violent, and beautiful engines of the early universe, and they hold the keys to some of its greatest secrets. The term quasar is derived from quasi-stellar object, meaning an object that almost resembles a star. This name was given because early astronomers, observing their incredible brightness, mistook them for very remote stars. In truth, they represent some of the most powerful phenomena we have ever observed. Picture a massive flashlight cutting through the blackness of a night without a moon. A quasar is much like that, but instead of a simple light beam, it's a cosmic beacon radiating energy on a scale that is difficult to comprehend. So, what is the source of this immense energy? The answer to that question is what makes these objects so captivating. Quasars are born from the activity of supermassive black holes, devouring matter at the core of galaxies. This consumption unleashes a colossal amount of energy, which we detect as visible light, along with other forms of radiation. At its core, a quasar provides a narrative about the universe in its infancy, as its light journeys for billions of years to finally reach our telescopes, allowing us to peer directly into the distant past. To understand how these titans of light come into being, you must know that matter does not simply fall straight into a black hole. Instead, it spirals inward, forming a rotating structure called an accretion disk. As this disk spins, it heats to incredible temperatures, generating a luminosity that can exceed that of thousands of galaxies put together. You can imagine it as millions of stars converging on a single point, emitting a light so intense it is visible across unimaginable cosmic distances. These objects are situated at incredible distances, effectively serving as windows into the universe's formative years. When you observe a quasar, you are not just seeing light, you are witnessing the very process of galactic formation unfold. The primary distinction between them and ordinary galaxies lies in their level of activity. While many galaxies exist in a state of relative calm, quasars are like cosmic adolescents, brimming with untamed energy and vigor, their brilliant light and erratic behavior setting them apart.
The history of quasars is not merely a scientific chronicle, but a true epic of discovery. During the 1960s, astronomers started to note certain objects in the sky that did not behave like typical stars or galaxies. It took time, but they eventually concluded that these were an entirely new class of celestial body. These objects were not only extraordinarily bright, but were also located at such immense distances that they offered a glimpse into the earliest epochs of the universe's existence. As our comprehension deepens, we recognize the profound connections at play, particularly the intimate link between quasars and supermassive black holes. Every quasar we detect signifies a black hole in the process of actively consuming matter and projecting energy across space. It's a kind of cosmic ballet, a complex interplay between the black hole and the surrounding matter that produces phenomena that constantly test the limits of our understanding. Interestingly, quasars are not all uniform. They come in various types, such as radio-loud quasars that are strong emitters of radio waves, and optically bright quasars, which are more prominent in the visible light spectrum. This diversity is crucial, as it helps us appreciate the universe's complexity and see how each quasar's behavior is uniquely shaped by its local environment and the specific conditions under which it was formed. When we consider the formation of galaxies, quasars assume a pivotal role, almost like architects overseeing the construction of cosmic structures. The tremendous heat and energy they release can significantly influence the surrounding gas and dust, potentially accelerating the birth of new stars, and, by extension, new galaxies. This leads to fascinating questions about whether a quasar's energy could have implications for the emergence of life elsewhere in the cosmos. Within the grand tapestry of the universe, quasars function as beacons that guide us through the vast darkness of space. They are instrumental in helping us map the expansion of the cosmos and comprehend its evolution over billions of years. Each new quasar observation provides us with more data about the universe's structure and the way galaxies arrange themselves into larger groups and superclusters. The light emanating from a quasar is far more than mere brightness. It is a direct message delivered from the past. By analyzing this light, scientists can deduce the chemical composition of the early universe and track how it has changed over time. The study of quasar light reveals crucial information about the distribution of matter across space and how that distribution has shifted throughout cosmic history. Ultimately, quasars are not just subjects of modern astronomical research. They have also ignited the imagination of many. Their depiction in popular culture, from movies to literature, demonstrates how these cosmic wonders have shaped our perception of the universe. They serve as a powerful reminder of our own smallness and the sheer vastness of the cosmos that envelops us. So, the next time you gaze upon a starry night, consider that some of those brilliant points might be quasars, their light traversing space and time to share stories that have waited eons to be told. Beginning in the 1960s, astronomers started observing a peculiar phenomenon in the heavens: brilliant and enigmatic glows that seemed to defy all known principles. The question of what they were became a genuine puzzle for the astronomical community. The solution was quasars. cosmic objects that appear like distant stars but are, in fact, powerful beacons of energy emanating from the very hearts of faraway galaxies. The journey to identify these cosmic titans was a landmark moment in science. The first quasar was formally recognized in 1963 by the astronomer Martin Schmidt. While observing an object that was emitting radiation at previously unseen wavelengths, Schmidt understood he had found something extraordinary. Its initial designation was quasi-stellar radio source, because it had the appearance of a star, but an entirely different and unexplainable behavior, which eventually led to the name we use today. Quasars stand out as some of the most compelling objects in the cosmos, but you might wonder what elevates them above other galaxies. To grasp their significance, you first need to understand their fundamental nature and what sets them apart from the galaxies you're familiar with. At their heart, quasars are the hyperluminous centers of distant galaxies, each one powered by a supermassive black hole. So, what is the source of their incredible brightness? The secret is rooted in the immense energy they produce. Picture a lighthouse cutting through the darkest night with its powerful beam to guide ships safely to shore. Quasars function in a remarkably similar fashion, but their light is generated by the tremendous energy unleashed as matter gets pulled into a supermassive black hole, creating a brilliance that can outshine thousands of galaxies combined. To truly understand the difference between a quasar and an ordinary galaxy, you can think of galaxies as cities. A typical galaxy is like a quiet town, where life moves at a steady pace within a relatively stable environment. A quasar, on the other hand, is a booming metropolis, overflowing with intense energy and ceaseless activity. While a normal galaxy consists of stars, planets, and gas, a quasar is in a dynamic state of growth, with its central black hole devouring matter at a staggering rate. Another key trait to consider is the variability of quasars, which can sometimes appear brighter or dimmer over time. This fluctuation is much like a city that shines more brilliantly during a festival or grows subdued in quieter moments. The brightness of a quasar can shift in a matter of days or weeks, which tells astronomers that the processes occurring near its central black hole are exceptionally dynamic and turbulent. One of the most astonishing facts about quasars is that they can be seen from almost unimaginable distances, meaning the light you observe has journeyed for billions of years to reach you. Every ray of light from a quasar is a message from the primitive universe, providing you with a direct window into its earliest epochs. Each flicker is an echo from the distant past, carrying information about how the first galaxies formed and how the cosmos has evolved. Through these cosmic echoes, researchers eventually understood that quasars were not merely astronomical oddities, but were instrumental in the evolution of galaxies. A brightly shining quasar releases so much energy that it can dramatically alter its galactic surroundings, a process known as feedback. This energy can heat the surrounding gas, preventing it from cooling and collapsing to form new stars, thereby influencing the very structure of the galaxy itself. For many years, astronomers grappled with the challenge of deciphering the secrets that quasars conceal. Early observations were centered on recognizing patterns in their light and refining the methods for detecting them. Major breakthroughs came with technological advancements, like powerful new radio and optical telescopes, which gave scientists the ability to study quasars with far greater precision, deepening our knowledge of these incredible objects. The scientific community has dedicated considerable effort to categorizing the different types of quasars, as they are not all identical. Some are distinguished by their intense radio emissions, while others are more notable in the optical part of the spectrum. This work led to further questions about what factors determine a quasar's properties, such as the mass of its black hole, the quantity of available matter to fuel it, and the orientation of its accretion disk. Intriguingly, some quasars are found within galaxies that are in the process of colliding, an event that can dramatically escalate the quasar's activity. You can visualize this interaction as two powerful rivers merging, causing the current to accelerate and become far more turbulent. These observations show us that quasars not only offer insights into black holes and star formation, but also reveal the dynamic and often chaotic nature of the universe. Ultimately, the history of quasar discovery is a testament not just to scientific progress, but to the power of human curiosity. Every new observation unlocks a universe of new questions, pushing us to ask what other secrets these luminous beacons still hold. As we continue this journey of exploration, quasars will serve as our guides, lighting the way to a more profound understanding of the cosmos. In contrast to the relative stability of a galaxy, a quasar is defined by its constant state of flux. This inherent dynamism leads to compelling questions about their impact on the cosmos, like how they shape their immediate environment or influence the evolution of other galaxies. As a quasar feeds on surrounding material, it unleashes a torrent of energy that can directly affect star birth and the overall mechanics of the galaxy it inhabits. The sheer scale of a quasar is staggering. It can exceed the size of our own galaxy by a factor of over 1,000. Try to envision an object so vast and brilliant that it would overshadow everything familiar to us. This incredible magnitude is a primary reason astronomers find quasars so endlessly fascinating. Every quasar acts as a cosmic lighthouse, lighting up its corner of the universe and simultaneously providing insights into cosmic history. The remoteness of quasars is also profoundly important. Because they typically reside in the centers of very distant galaxies, observing them is equivalent to peering deep into the past. This gives us a unique opportunity to study the characteristics of galaxies during the earliest eras of the universe's existence, and helps us understand how the largest cosmic structures were first assembled. It's possible that quasars are the key to unlocking answers to some of the most fundamental questions about cosmic origins. The light they produce is extraordinary. Beyond its sheer intensity, it carries valuable data about the elemental makeup of the universe. Each wavelength can provide specific details on the temperature, density, and velocity of the matter enveloping the quasar, almost like an encrypted signal sent across the cosmos that scientists are working diligently to decipher. With every step forward in our knowledge of quasars, new puzzles and questions emerge. We are left to wonder what more they will teach us about the part black holes play in the creation of galaxies, or how their immense energy output shapes the universe's evolution. Each new finding about these objects brings us nearer to comprehending the intricate workings of the cosmos. From the moment they were discovered, the tremendous energy radiating from quasars has captivated astronomers. The central mystery is how a comparatively small object can shine with such ferocious intensity. To grasp this phenomenon, we need to examine the core of these cosmic behemoths, which are fundamentally the active centers of galaxies, powered by supermassive black holes. As material draws closer to one of these black holes, it gets caught in an accretion disk, a swirling vortex of gas and dust rotating at incredible velocities. The significance of this process lies in what happens next. The matter heats to unimaginable temperatures as it spirals inward. Think of the intense friction generated when you rub your hands together, but on a cosmic scale. For quasars, this immense heat converts into energy that is then unleashed as powerful light and radiation. Just how powerful is this energy release? To give you a sense of scale, one quasar alone can radiate more energy than thousands of entire galaxies put together. It's truly remarkable to consider that there are light sources capable of outshining countless stars, a fact that makes them detectable from billions of light years away. In essence, quasars serve as cosmic lighthouses, piercing the vast darkness of space to guide our observations.
A quasar's energy output is not confined to the visible spectrum. It also radiates powerfully in X-rays and radio waves. You can think of it as a lighthouse that transmits signals across multiple frequencies, not just a single beam of light. This multi-frequency emission enables scientists to observe quasars from different perspectives, which leads to a much fuller picture of these captivating celestial objects, with each wavelength offering new clues about the core processes and surrounding material. The interplay between the supermassive black hole and the surrounding matter is fundamental to explaining this energy production. As material is pulled in, it is rapidly accelerated and compressed, resulting in a monumental discharge of energy. The efficiency of this mechanism is so great that it makes stellar nuclear fusion, the universe's most prevalent energy source, appear feeble by comparison. It's almost as if you're comparing a star's finite power supply to a quasar's seemingly limitless energy source. The energy unleashed by a quasar is also a critical factor in the way galaxies evolve. During a quasar's active phase, its powerful radiation can directly impact the birth of new stars within its own host galaxy. This occurs because the intense radiation heats up and blows away the surrounding gas clouds, effectively shutting down or restricting further star formation. This mechanism, which astronomers call feedback, is essential to our understanding of how galaxies transform throughout cosmic history. Furthermore, a quasar's influence extends beyond its own galaxy to the wider galactic neighborhood. Picture it as a tremendous storm propagating shock waves through space. These waves are capable of compressing distant gas clouds, which can trigger the birth of new stars in regions that had been dormant. This interplay represents a cosmic balance of creation and destruction, with the quasar's energy serving as a catalyst for the emergence of new stellar generations. Curiously, the study of quasar energy also provides us with a deeper comprehension of the universe's expansion. Scientists can determine how fast a quasar is receding from us by measuring the degree to which its light has shifted toward the red part of the spectrum. This effect, referred to as redshift, is a cornerstone of modern cosmology, positioning quasars as vital beacons that light the way toward unraveling the universe's history. It's truly astounding that, despite the immense gulf of space between us, the energy from quasars enables us to learn about the universe's first moments. Each observation is a journey back in time, often by billions of years, giving us a view that resembles a motion picture of cosmic history. As you may know, quasars are intrinsically tied to one of the cosmos's greatest mysteries, supermassive black holes. These giants occupy the hearts of most galaxies, and their presence is absolutely essential for the existence and activity of quasars, which raises the question of what the precise nature of their relationship is. To find the answer, we must embark on a journey into cosmic physics. Quasars are incredibly luminous sources of light and energy, their brilliance generated by matter spiraling into a supermassive black hole. Picture a massive whirlpool, where water rushes toward the center, creating a powerful vortex. A similar phenomenon occurs within a black hole's accretion disk, where the inflowing material unleashes a tremendous amount of energy, causing the quasar to shine so intensely. So, what exactly is a supermassive black hole? You can think of these objects as cosmic titans with masses that are millions or even billions of times greater than our Sun. Their gravitational pull is so immense that nothing, not even light, can escape their grasp. Yet, despite this inherent darkness, a black hole surrounded by a feast of infalling material
transforms into one of the brightest beacons in the cosmos, which is precisely what we observe as a quasar. But how does a quasar actually come into being? It all starts at the core of a developing galaxy, where a black hole begins to draw in surrounding gas and dust. This material doesn't fall straight in. Instead, it organizes itself into a rotating disk, much like the rings of Saturn. As this matter accelerates and becomes compressed, it heats to extreme temperatures and radiates energy as light and other wavelengths, turning the black hole into a quasar that is visible across billions of light years. The relationship between quasars and black holes is even deeper, as a quasar's activity can profoundly influence the development of its host galaxy. Imagine a quasar acting as a cosmic lighthouse that not only illuminates its surroundings, but also actively reshapes them. By blasting out colossal amounts of energy, quasars can heat the gas throughout their galaxy, which in turn affects the rate of new star formation and can alter the entire structure and ultimate fate of the galaxy itself. Furthermore, quasars serve as invaluable tools for probing the universe. By studying the light that travels from a distant quasar to us, astronomers can investigate the intergalactic medium that fills the space between galaxies. This medium subtly alters the light passing through it in fascinating ways. Analyzing these changes provides scientists with vital clues about the composition and evolution of the cosmos, making quasars cosmic messengers that tell us about the matter and energy in the vast voids of space. You might be wondering if every supermassive black hole transforms into a quasar. The answer is actually no. A black hole shines as a quasar only when it is in an active phase of accreting or feeding on surrounding material. It can experience long stretches of inactivity if there isn't enough matter available to generate that intense light. This reveals a cycle where a quasar's activity fluctuates over time, making some black holes visible only during specific moments of their existence. It is also important to understand the different varieties of quasars, as they are not all uniform. Some are exceptionally bright and emit powerful radiation at radio frequencies, whereas others are more prominent in the optical spectrum. This diversity arises from factors like the quantity of material encircling the black hole and the specific orientation of its accretion disk relative to our line of sight. Much like stars in the night sky, each quasar possesses its own distinct characteristics. The link between quasars and black holes is not just scientifically compelling. It also forces us to consider fundamental questions about the universe's nature. How did these galactic giants steer the course of galaxy formation? What is their role in the broader expansion of the cosmos? Answering these questions is essential to advancing our modern understanding of cosmology and our place within it. Finally, it's crucial to appreciate that quasars are phenomena that connect us directly to the universe's distant past. Because the light from a quasar may travel for billions of years to reach us, observing one is like looking through a time machine at the cosmos as it was in a much earlier epoch. This provides a unique window for exploring cosmic history and understanding how our reality came to be. So the next time a quasar comes to mind, remember that it is far more than a brilliant point of light in the cosmic darkness. It is a keeper of secrets about supermassive black holes and the immense universe we all inhabit. The dynamic between quasars and black holes remains one of the most captivating narratives in astronomy, and its study continues to unveil new cosmic mysteries. Imagine a vast cosmic ocean dotted with brilliant lights, like beacons shining in the dark. In this expanse we find quasars, but you should know that these objects are not all the same. They come in different types, each with its own fascinating qualities. Today we're going to delve into the various classifications of quasars and explore what makes each one unique. Let's begin with the term quasar itself, which is a broad designation for all the intensely bright objects of this kind we see in the universe. Within this general grouping, however, distinct types emerge based on their specific properties. For instance, there are radioluminous quasars. Their special feature is their capacity to emit radio waves with an intensity far exceeding that of other quasars. This happens because they produce powerful jets of particles that are launched into space at nearly the speed of light, like enormous cosmic cannons firing matter at unbelievable velocities. On the other side of the spectrum, we find optically bright quasars. These are the ones that radiate with extreme intensity in the wavelengths of visible light. You can think of them as the rock stars of the cosmos, commanding the attention of both professional astronomers and amateur enthusiasts. Their light is so powerful it can be detected from billions of light years away, giving us a remarkable glimpse into the universe's ancient history. Their origin lies with supermassive black holes that generate immense energy as they consume matter. However, that's not the end of the story. There is another, perhaps even more captivating category to consider: the high redshift quasars. These celestial objects are situated at such immense distances from our planet that the light we observe from them is a relic from the past, a time when the cosmos was significantly younger. If you think of time as a flowing river, we are essentially gazing upstream into its current. Quasars offer us an unparalleled glimpse into cosmic history, enabling our study of how the very first galaxies came into being. When you examine the various kinds of quasars, a compelling question emerges. How can we tell which specific type we are looking at? To answer this, astronomers employ a method called spectroscopy, which involves separating light into its fundamental components. This allows them to identify the chemical fingerprints left by elements within the quasar's emitted light, which is crucial for determining its classification, much like a cosmic detective analyzing evidence to unravel the mysteries of these remote objects. Beyond this, variability serves as another essential distinguishing feature, as some quasars can alter their brightness over brief intervals, while others maintain a more steady luminosity. This happens because quasars are not static phenomena. They are constantly evolving. Fluctuations in their brightness can offer clues about the dynamics occurring within the supermassive black holes at their cores, similar to how a lighthouse's flashing beacon can reveal secrets about its internal mechanisms. Some quasars also display features that challenge our current models, exhibiting complex structures within their emissions that suggest processes more intricate than we had first imagined. You could think of these particular quasars as unique works of art scattered across the universe, each with its own distinctive story and set of characteristics to share. The diversity found among quasars is not merely a fascinating subject on its own. It is fundamental to our deepening comprehension of the universe. Each type of quasar contributes valuable data regarding the formation and evolution of galaxies, as well as the underlying nature of dark matter and dark energy. It's akin to assembling a cosmic puzzle, where every piece is a quasar, and by fitting them together, we achieve a more complete image of the universe's structure. However, the system for classifying quasars is not set in stone. As our research advances, it is highly probable that we will uncover new categories or refine the existing ones. Technological breakthroughs, including more powerful telescopes and sophisticated observational techniques, are constantly providing us with information that challenges our prior assumptions, adding new layers of complexity to our knowledge of these extraordinary cosmic objects. So, what part do quasars play in the birth and development of galaxies? To understand their role, you should first envision a grand ballroom set against the backdrop of cosmic darkness. In this scene, quasars act as brilliant strobe lights, while galaxies are the dancers gracefully moving around them. These lights don't just illuminate the ballroom, they actively influence the dancers' movements, shaping their patterns and forms. As immensely powerful energy sources, quasars function as catalysts in the evolutionary journey of galaxies. When a quasar ignites, it releases enormous quantities of radiation that can profoundly affect its surroundings. You can imagine each beam of light it projects as a powerful gust of wind, capable of pushing galaxies, causing them to merge, diverge, or change their shape, thereby guiding their development across cosmic timescales. But how, precisely, do these potent cosmic beacons exert their influence? One of the most compelling mechanisms is through the radiation they emit, which not only brightens space, but also heats the surrounding gas and dust. Consider a campfire. If you approach too closely, the intense heat compels you to move back. In a similar fashion, quasars heat the gas in their vicinity, which can destabilize it and trigger the formation of new stellar material. Consequently, quasars are not just passive luminaries. They are active engines of creation within the universe. As galaxies drift near a quasar, they become bathed in its light and energy, a process that can accelerate their own activity. This is analogous to a plant that grows more rapidly when it receives intense sunlight. In this way, quasars can be seen as beacons guiding the growth of new stars in nearby galaxies, contributing to the diversity and evolution of the cosmos. It's important to note, however, that not all quasars produce the same outcome. Some might act as a gentle beacon, offering slow guidance, while others are explosive, triggering dramatic shifts in their environment. This variability prompts a question. What dictates a quasar's strength? The answer is found in the quantity of matter being consumed by the supermassive black hole at its heart. The more matter it accretes, the more energy is released, and the greater its influence on neighboring galaxies becomes. When a quasar feeds on matter, it can launch jets of high-energy particles that travel across the cosmos. These jets are like massive fireworks exploding in the night sky, illuminating everything around them. These events are not only visually spectacular, but can also extend over enormous distances, impacting galaxies located millions of light-years away. You can compare this to the effect of thunder during a storm, whose deep rumble can be heard from afar, disrupting the surrounding peace. What occurs when a quasar is in a period of inactivity? Although its light may fade temporarily, its influence over galaxies does not simply vanish. The cosmic structures that were formed during its active phase can continue to shape galactic development for millions of years afterward. This implies that the impression left by a quasar can have a long-term impact, well after its brilliant light has subsided. Within the context of galaxy formation, quasars also serve a critical function by regulating the supply of gas available for the creation of new stars. Their role is similar to that of a gardener who controls water and light to ensure plants grow in a healthy manner. If a quasar emits an excessive amount of radiation, it can heat the gas to a point where it is unable to collapse and form stars. Conversely, a moderate level of radiation can create the ideal conditions for new stars to emerge. Furthermore, the dynamic interaction between quasars and galaxies can give rise to fascinating phenomena, including the creation of vast galactic structures that form filamentary shapes. This process highlights their power not just to affect individual galaxies, but to actively sculpt the very fabric of the cosmos on the largest scales imaginable. Quasars, those brilliant and enigmatic energy sources in the cosmos, captivate us with more than just their incredible luminosity. Their specific location is equally fascinating. To grasp their position in the grand cosmic scheme, you must first understand their connection to the galaxies they inhabit and their pivotal role in universal evolution. Essentially, when we talk about quasars, we are describing objects that reside at the very heart of far-off galaxies. So, what are the implications of this for our perception of time and distance? When you gaze at a star, you're actually seeing light that has journeyed for millions of years to reach you. With quasars, that journey stretches across billions of years, offering you a direct view of the universe in its infancy. This experience is akin to a form of time travel, enabling us to witness the cosmos during its formative stages and follow the light of these beacons back to the dawn of our existence.
One of the most compelling aspects of a quasar is its direct link to a supermassive black hole, which sits at the core of each one, devouring matter with incredible speed. Think of the black hole as a cosmic whirlpool, pulling in all surrounding material. As this matter spirals inward, it heats to extreme temperatures and unleashes a staggering amount of energy, which you perceive as the brilliant light of the quasar. This energetic process does more than just make the quasar shine. It profoundly impacts the entire host galaxy, guiding its developmental path. By studying quasars, we gain profound insights into the fundamental properties of cosmic matter and energy, as these brilliant objects serve as powerful indicators of activity within their host galaxies. In essence, a quasar reveals the biography of its galaxy, detailing its formation, its history, and its encounters with other cosmic entities. These celestial bodies are witnesses to the universe's past, allowing astronomers to piece together the story of how galaxies have developed over eons. Analyzing their light and behavior is like reading a cosmic chronicle, with each observation turning a new page on the universe's history. Examining the arrangement of quasars throughout the cosmos also teaches us about their origins and their relationship with dark matter. While this enigmatic substance is invisible to us, its gravitational effects are unmistakable. By charting the positions of quasars, scientists can deduce the underlying structure of the universe and understand how dark matter sculpts the cosmic web. It's a bit like assembling a jigsaw puzzle with many missing pieces, where each new quasar discovery helps to clarify the overall image. The ongoing expansion of the universe is another phenomenon that quasars help us to comprehend. The light traveling from them is stretched by the fabric of expanding space, providing vital clues about the rate and direction of this cosmic growth. This serves as a potent reminder that the universe is in a state of perpetual change, and quasars act as our navigational guides through this dynamic exploration. The placement of quasars further highlights their cosmological significance, as they are typically situated in areas of heightened galactic activity, strongly implying a connection to the mechanisms of galaxy formation. Furthermore, observations reveal that there is more to a quasar than its brilliant light alone. They are enveloped in vast clouds of gas and dust, which can alter their perceived brightness and hue, meaning this dynamic environment is a crucial part of their story and affects our view of them from Earth. Quasars are also indispensable for probing the epoch of recombination, a pivotal era in cosmic history when light from the earliest stars and galaxies began to ionize the neutral hydrogen filling space. By analyzing quasars from that time, researchers can unlock secrets about the assembly of the universe's first structures. As our technology progresses, so too do the techniques we use to observe these distant phenomena, promising even deeper understanding. This influence can manifest as vast filaments, reminiscent of a tree's branches, with each offshoot signifying a galaxy whose development is shaped by a neighboring quasar. Such structural growth patterns serve as powerful evidence of the role quasars play in orchestrating the large-scale architecture of the universe. Consider what happens when a quasar's host galaxy is in the process of merging with another. This cosmic collision can dramatically amplify the quasar's activity and unleash a surge of new star formation. Much like two converging rivers create a turbulent and powerful current,
These galactic mergers establish quasars as potent agents of change, steering the evolution of galaxies toward entirely new shapes and configurations. It's also fascinating to contemplate how these interactions might have contributed to the formation of our very own Milky Way. From the universe's earliest moments, quasars have served as a consistent thread weaving through cosmic history and lighting the way for galactic evolution.
So the next time you gaze up at the night sky, I want you to see those stars as more than just distant points of light. Recognize them as cosmic lighthouses that have guided the intricate dance of galaxies, sculpting the very fabric of the cosmos as you know it. Quasars remain central actors on this immense stage, and their epic story is still unfolding. Thanks to more powerful telescopes and innovative techniques, astronomers can now capture increasingly intricate details about these far-off celestial objects. Each new revelation concerning quasars not only helps complete the cosmic puzzle, but also prompts new questions about the fundamental workings of the universe. When you study quasars, you come to appreciate that even from billions of light-years away, their influence extends to us here on Earth, reminding you that we are all part of a vast, interconnected existence. Therefore, delving into the nature of quasars is as much a reflection on our own cosmic reality as it is an exploration of the unknown. As our pursuit of knowledge advances, quasars are certain to be an endless wellspring of wonder and remarkable new insights. When you look up at the night sky, a fundamental question often emerges. How did the very first stars and galaxies ever manage to form in a universe that was so chaotic in its infancy? In this grand narrative, quasars serve a crucial function, acting as brilliant beacons that illuminate our journey toward understanding cosmic history. But what makes them so vital to the process of the universe's reionization? To grasp their importance, you first need to picture what occurred in the moments following the Big Bang, when the universe was shrouded in a thick fog of particles and radiation. As this primordial haze gradually cooled, electrons and protons merged to create hydrogen atoms, yet this did not make the cosmos transparent. The situation only began to shift when the first stars ignited, generating the light and heat needed to finally disperse the obscuring fog that filled all of space. It is at this point that quasars make their dramatic entrance. These objects are exceptionally luminous, and their immense energy is believed to be generated by supermassive black holes at their centers. As these cosmic behemoths devour surrounding matter, they unleash an extraordinary amount of energy as light, a process that both illuminates the cosmos and profoundly alters the environment around them. The brightness of a single quasar can, in fact, outshine that of thousands of entire galaxies combined. When a quasar activates, its intense radiation is powerful enough to ionize the hydrogen gas in its vicinity, which is the key to cosmic reionization. This process forces electrons and protons to separate once more, transforming the opaque universe into a transparent one. In essence, quasars functioned as colossal lighthouses, their energy heating and lighting up the cosmos until the fog of the cosmic dark ages was finally lifted. But how does this clearing of the cosmic fog connect to the assembly of the first galaxies? The light emitted by quasars did more than just burn away the hydrogen haze. It also shaped how other cosmic structures began to congregate. As the universe became transparent, galaxies started to take shape and gather into clusters, giving rise to a more complex cosmic architecture. Because quasars signify intense activity in the early universe, they allow you to trace the evolution of these galactic clusters across time. So, how prevalent were quasars during this era of reionization? It is thought that they reached their peak activity approximately 11 billion years ago, a time when the universe was merely a third of its present age. During that period,
Quasars were far more numerous, and their brilliant light was instrumental in reshaping the entire cosmic landscape. By examining these incredibly distant objects, astronomers can uncover valuable clues about the conditions of the universe in its earliest stages.
This raises an interesting thought. Could you have ever witnessed a quasar yourself? If you could travel back in time, you would be able to observe these cosmic beacons as they blazed through the darkness of space. The light from these quasars, having traveled for billions of years to reach us today, provides an unparalleled window into the distant past, allowing us to see the universe as it once was. Quasars also offer precious information regarding the universe's chemical composition and the ambient conditions during its youth. By analyzing the spectrum of light they emit, scientists can identify the quantities of various elements and compounds that existed in the primordial cosmos. This knowledge not only deepens our understanding of cosmic chemistry, but also yields insights into the evolutionary paths of stars and galaxies. Moreover, the relationship between quasars and galaxies extends well beyond the era of reionization. Throughout cosmic history, the intense radiation from quasars has had the power to influence the formation and development of galaxies. Their energy can impact the surrounding gas, effectively regulating the speed of star formation and controlling the growth of the galaxy itself, which adds another layer to our understanding of universal evolution. What is the significance of quasars in the modern era? Although the vast majority are billions of light-years away, their study continues to be exceptionally relevant for understanding not only the universe's past, but also its future. As scientific inquiry progresses, quasars may hold the keys to deciphering some of the greatest cosmic enigmas, including the true nature of dark matter and dark energy. It is truly remarkable to consider how these remote cosmic lighthouses have sculpted the history of our universe. From triggering reionization to guiding the formation of galaxies, their impact has been both profound and lasting. When you gaze into the night sky and contemplate their ancient light, you are connecting with a distant past, deepening your understanding of our own position within this immense and mysterious cosmos. Observing phenomena that are situated billions of light-years away is made possible through the sophisticated methods astronomers employ to study quasars. These distant beacons are far more than just brilliant specks in the sky. They are carriers of invaluable information about the very fabric of the cosmos. Studying them prompts fascinating questions, such as what kinds of light they produce and, more importantly, how you can possibly analyze it from so far away. But what are the most important secrets these cosmic beacons can reveal? The light from quasars spans a vast spectrum of wavelengths, encompassing everything from radio waves to X-rays. This emission is a composite of different forms of electromagnetic radiation, and each one offers you a window into the quasar's characteristics and behavior. Visible light is the portion of the spectrum your own eyes can perceive, but countless other forms of light remain invisible to us. Telescopes serve as our powerful instruments for capturing these unseen wavelengths, transforming intangible energy into concrete information for study. A truly fascinating quality of the light quasars emit is its sheer intensity, with some of these sources being so luminous they can actually outshine their entire host galaxies. This extraordinary brilliance is a direct result of the immense energy unleashed as matter spirals into the supermassive black hole at the quasar's core. But how can you determine a quasar's distance using only its light? The answer is found in a concept known as redshift. This phenomenon occurs as light waves stretch out when an object recedes from us, meaning the farther away a quasar is, the more pronounced its redshift will be, which allows us to calculate its distance with remarkable accuracy.
Technological progress has been astonishing, and we now possess space-based observatories like the Hubble Space Telescope and the Chandra X-ray Observatory. These instruments are capable of detecting the wavelengths that Earth's atmosphere filters out. It's like having a telescope that can see far beyond what your eyes are capable of perceiving. And thanks to these tools, we've successfully identified thousands of quasars and investigated their properties in meticulous detail.
By analyzing a quasar's light, scientists can deduce the chemical makeup of its environment through a method called spectroscopy, which separates light into its component wavelengths. Every chemical element imprints a distinct signature on this spectrum, so by simply observing the light a quasar emits, you can identify the specific gases and materials that surround it. Isn't it incredible to realize that light itself can carry a message, revealing the very building blocks of the cosmos?
Furthermore, you can use the light from quasars to map the large-scale structure of the universe. When a quasar aligns with another celestial body, its light can be bent by gravity in a phenomenon called gravitational lensing. This effect lets us see objects that would otherwise be hidden from view and gives us a better understanding of how matter is distributed throughout the universe. Studying the light from quasars also brings up questions about the universe's development. By observing quasars from different cosmic epochs, astronomers can compare their brightness and features to see how they have transformed over billions of years. This process is much like flipping through a family photo album, offering you insights into how these objects have grown and evolved.
So, what is the relationship between quasar light and the expansion of the universe? As space itself expands, the light from distant quasars moving away from us gets shifted toward longer wavelengths in what is known as cosmological redshift. This effect not only helps you measure the speed at which these objects are receding, but also provides critical data on the rate of the universe's expansion. Observing a quasar means you aren't just looking at a faraway object. You are witnessing processes that have unfolded over billions of years, giving you a direct window into the universe's past. This light helps us comprehend extreme events, including the formation of black holes and the intricate dynamics of galaxies. However, observing these distant phenomena isn't without its difficulties, as cosmic dust and gas can sometimes obscure a quasar's light and complicate its study. Despite these obstacles, astronomers have devised clever ways to overcome them, employing telescopes that operate at various wavelengths and sophisticated data correction techniques. The future of quasar observation appears bright, with more advanced telescopes and space missions on the horizon. What new discoveries are waiting for us? Will the light from quasars finally help you unlock the secrets of dark matter and dark energy? Only time will provide the answers. The light from quasars is like a message sent from the deepest parts of the cosmos, a whisper of energy traveling for billions of years just to reach us. But what precisely is this light communicating? To find out, you must explore the nature of the radiation these captivating celestial bodies emit. Quasars are often referred to as the beacons of the cosmos, and with good reason, as their brilliant light can be seen from the farthest corners of the universe. In fact, the light they produce is so incredibly intense that it frequently outshines the combined light of thousands of galaxies. This begs the question, how is such a feat possible for an object that is relatively small compared to its surroundings? The solution is found in their cores, which harbor supermassive black holes. As matter is pulled toward these cosmic giants, it heats to unimaginable temperatures, radiating enormous energy as visible light, X-rays, and radio waves, effectively turning quasars into powerful light factories. To understand this, you can imagine building a campfire. At first, the flames might be small, but as you add more fuel and tend to the fire,
it grows into a dazzling spectacle. In much the same way, the matter that falls into a black hole acts as fuel, dramatically amplifying the quasar's brightness. Ultimately, the light from quasars not only illuminates the cosmos, but also provides you with a profound understanding of the universe's history and evolution. Each burst of light tells a unique story, and every quasar is a testament to the cosmic events that have shaped our world. The incredible luminosity of a quasar originates from its accretion process, where matter spirals into a supermassive black hole. Yet, beyond this sheer brightness, what other secrets can we uncover from its light? This light is far more than just brilliant. It serves as a detailed messenger from across the universe. Using a principle known as redshift, which measures how light stretches during its cosmic journey, scientists can decipher a quasar's velocity and trajectory, almost like reading a unique celestial fingerprint. The degree to which a quasar's light has shifted reveals its distance from us, providing direct evidence for our expanding universe and giving us insights into the cosmos's history and evolution. By examining this ancient light, astronomers can also deduce the chemical makeup of the material surrounding these distant giants. You can think of the light being separated into its constituent colors, much like a rainbow, creating a spectrum that exposes the specific elements present in the quasar's vicinity.
Through this spectral analysis, researchers have identified elements like hydrogen, helium, and even heavier metals. This discovery suggests that quasars are not merely cosmic lighthouses, but are in fact vast laboratories where the fundamental building blocks of the universe are forged and scattered. Furthermore, the light from these objects has been instrumental in helping us understand a critical event in cosmic history: the reionization of the universe, which was essential for the formation of galaxies and stars as we know them. However, interpreting this light is not always a simple task, as its journey to us is fraught with obstacles. As the light traverses immense clouds of interstellar gas and dust, it can be absorbed or scattered, which significantly alters its properties by the time it reaches our telescopes. This effect is much like trying to view a distant lighthouse through heavy fog. The environmental conditions can distort the very data we are trying to analyze, presenting a significant challenge for astronomers. What I find equally compelling is how the analysis of quasar light has advanced our knowledge of dark matter. Although dark matter is invisible, its gravitational pull bends the path of light, a phenomenon that we can detect. By studying how a quasar's light is distorted as it passes near massive, unseen objects, scientists can map the distribution of dark matter throughout the cosmos, effectively using light as a probe to explore the unseeable. When you truly consider the implications, you realize that quasars function as extraordinary windows into the distant past. Because these objects are so incredibly far away, the light we observe from them today began its journey billions of years ago. This allows us to witness the universe in its infancy, offering invaluable clues about the formation of the very first stars and galaxies, and observing cosmic evolution in action. This same principle has enabled astronomers to use quasars as cosmic landmarks for charting the universe on its grandest scale. By observing the positions of countless quasars, we can delineate the vast architecture of the cosmos, revealing the intricate web of matter and voids. This large-scale map is crucial for comprehending the dynamics of the universe and how its structure has transformed over eons. It is truly humbling to consider the vast number of questions that still await answers. Every new quasar we study presents another chance to deepen our understanding of fundamental physics. As our technology progresses, the instruments we use to analyze quasar light grow ever more powerful, and with superior telescopes and sophisticated data analysis, the future of this research appears incredibly bright. Ultimately,
The light from quasars does more than satisfy our scientific curiosity. It forges a profound connection between us and the immense universe we inhabit. Each photon that completes its billion-year journey is a reminder of our own scale against the backdrop of a boundless cosmos. In studying this light, you are not just exploring the universe, but you are also gaining a deeper understanding of our own place within it. Quasars can function as beacons that signal the existence of dark matter, the enigmatic substance that constitutes the majority of the universe yet remains invisible to us. By analyzing the light patterns emanating from these cosmic objects, scientists can deduce the influence of dark matter on the surrounding space, effectively allowing them to chart this unseen material. Because some quasars are located at immense distances, their light has journeyed across space-time from eras when the cosmos was fundamentally different, offering you a unique window into the primeval universe, a time when matter and energy were in a constant state of flux. The relationship between quasars and black holes is also fundamental to comprehending the expansion of the universe. At their core, quasars are supermassive black holes that are furiously devouring surrounding matter, a process that unleashes tremendous quantities of energy and enables them to radiate with an almost inconceivable brightness. The effects of this activity extend beyond their home galaxy, influencing the dynamics of neighboring galaxies and demonstrating that quasars are integral components of a much larger cosmic system. The investigation into quasars and their connection to the universe's expansion is far from over. With ongoing technological progress, researchers are developing novel methods to examine these extraordinary cosmic phenomena. More powerful telescopes and sophisticated observational techniques may soon provide you with answers to questions that are currently beyond our imagination, raising the question of what the next wave of quasar research will uncover about the fundamental nature of space and time. Furthermore, the observation of quasars can offer insights into other cosmic events and structures. For instance, by studying how a quasar's light is altered by dark matter, scientists can deduce the existence of other massive formations, including entire galaxies and clusters of galaxies. In this way, every quasar you observe becomes another piece in the grand puzzle, contributing to our understanding of cosmic expansion and the interconnectedness of all things. It's truly remarkable to consider that observing a quasar is akin to taking a journey through the annals of time and the vastness of space. The light from that object has traversed immense distances and navigated numerous obstacles on its long path to reach you. This epic voyage is a testament not only to the endurance of light itself, but also serves as a profound reminder of the intricate connections between all elements within the cosmos. Ultimately, it is crucial to recognize how these discoveries do more than just expand our scientific understanding. They also compel you to contemplate your own place within the cosmos. So, the next time you find yourself gazing at the night sky, remember that any one of those brilliant specks of light could be a quasar, a portal linking you directly to the universe's past and the marvel of the great unknown. Investigating quasars is therefore not merely a scientific pursuit, but also a profound journey toward understanding our own identity and our role within the immense and enigmatic universe. Having captivated the minds of both astronomers and amateur space lovers, the appearance of quasars in popular culture stands as a testament to the awe they provoke. These remote and enigmatic celestial bodies have been woven into our narratives, movies, and music, illustrating a fascination that transcends their purely scientific importance. Moreover, they have motivated artists and writers to delve into themes of endlessness, enigma, and the sheer power of the cosmos. A common question arises: what is the actual distance to these quasars? The answer is nothing short of staggering, as some are so profoundly distant that their light has been traveling for billions of years just to reach us. This ancient light not only reveals a glimpse of the universe in its infancy, but also prompts you to reflect on your own existence within such a vast cosmos. Narratives in science fiction frequently depict quasars as luminous points in the void, acting as guiding lights for explorers traversing the galaxies. Popular films and series, such as Star Trek or Interstellar, employ ideas like wormholes and voyages near quasars to build captivating stories centered on cosmic exploration. Within these tales, quasars symbolize more than just a physical destination. They embody the hope for new discoveries and adventures that lie beyond the frontiers of our current knowledge.
The impact of quasars can also be seen throughout the world of visual arts, where painters and sculptors draw inspiration from the concept of these celestial lighthouses, producing works that encapsulate their mystical quality and the sheer scale of the cosmos. In the realm of literature, quasars frequently serve as allegorical devices representing life and death, or the cycles of beginnings and endings. Authors often explore the concept that our lives can be radiant and impactful, much like a quasar's light, even if they last for just a fleeting moment in the grand timeline of the universe. The widespread appeal of quasars is also apparent within the field of education. Through books and documentaries aimed at younger viewers, new generations are introduced to the captivating domain of astronomy. Presenting quasars as incredible natural wonders helps ignite a passion for science and cosmic exploration, motivating the next wave of researchers to carry this work forward. It is worth noting, however, that the depiction of quasars in popular culture does not always adhere to scientific accuracy. In popular culture, the traits of quasars are frequently amplified or assigned qualities that they don't actually have. This sparks a fascinating discussion. Is it vital for science and fiction to stay in separate domains, or could fiction act as a gateway to comprehending intricate scientific principles? While the answer is debatable, the bond between science and popular culture is clearly powerful. As quasars continue to fascinate the public, their significance in entertainment and art shows no sign of fading. Every new insight into these cosmic phenomena ignites our curiosity and fuels our imagination, leading to new artistic creations, songs, and tales about our place in this immense universe. Furthermore, the reality that quasars are some of the most brilliant and remote objects observable serves as a constant reminder that there is always more to learn. The identification of each new quasar presents fresh inquiries and narratives, pushing us to test the limits of human understanding and sustaining our collective drive to know the cosmos. Ultimately, quasars represent more than just subjects of astronomical research. They are emblems of humanity's drive for knowledge and connection. Their reflection in popular culture mirrors a deep-seated human impulse to explore, comprehend, and discover meaning within the staggering scale of the universe. Though they may be incredibly distant and enigmatic, their light persists in illuminating the minds and hearts of all who look to the sky, encouraging future generations to dream of the stars. Whenever you encounter a quasar in a movie or a song, remember that you are witnessing more than an astronomical event. You are seeing a symbol of human curiosity, a beacon that shines relentlessly against the cosmic darkness. And now, we will delve into their connection with an even more profound mystery: dark matter. To grasp the concept of dark matter, you have to envision the universe as an enormous jigsaw puzzle, where some of the pieces are completely invisible. We are unable to see this substance directly, yet we are certain of its existence, due to the observable effects it has on its surroundings. Quasars, in this analogy, are some of the most brilliant and visible pieces of the puzzle, acting as beacons that not only light our path, but also offer clues about the universe's hidden components. The extreme brightness and distance of quasars give us a singular advantage in studying dark matter.
Their light, which travels for billions of years before reaching our telescopes, carries the history of the galaxies and cosmic structures it has traversed. As this ancient light journeys through space, it is bent and distorted by the gravitational pull of dark matter surrounding galaxies, a phenomenon known as gravitational lensing.
This gravitational lensing serves as a powerful instrument for astronomers. By carefully analyzing the distortions in a quasar's light, scientists can deduce the quantity and arrangement of dark matter across the universe. It is much like using the clues on a map to locate a hidden, invisible treasure. The light from quasars guides you toward the location of this unseen cosmic fortune, revealing crucial information about the universe's composition. The relationship between quasars and dark matter also brings up fascinating new questions. Some theories propose that the presence of a quasar might indicate a massive concentration of dark matter, meaning that observing one gives us a view not just of its central supermassive black hole, but also of the entire dark matter-dominated environment it inhabits. Dark matter is also understood to be fundamental to the formation of galaxies. According to computer simulations, without the gravitational scaffolding provided by dark matter, galaxies would simply lack the force needed to pull together into stable structures. Quasars, typically found at the core of these galaxies, can therefore be seen as direct witnesses to this essential cosmic construction process. Yet, the link doesn't stop there. Researchers are exploring the use of quasars as cosmic yardsticks to measure the expansion of the universe. By observing how quasar light is affected by dark matter at various points in cosmic history, scientists can gather valuable data on how the density of dark matter has evolved over eons. Imagine that quasars are lighthouses in an ocean of cosmic unknowns. As we navigate this expanse, they help us map the islands of dark matter and comprehend the invisible currents that shape the cosmos. Each time we observe a quasar, it's as if a switch is flipped in the darkness, revealing something new about the universe that envelops us. Despite all the progress in this research, a great deal remains unknown. Why does dark matter appear to be so plentiful in some areas of the universe, but not others? What precise role does it play in the birth and eventual death of quasars? Every answer we uncover only seems to generate more questions, which makes the study of this connection a perpetually fascinating field. As our exploration of this relationship continues, we may find that quasars are more than just objects of interest. They could be the very keys needed to unlock the deepest secrets of our universe. Dark matter might be the unseen thread that weaves the entire cosmos together, and quasars may be the luminous guides that help us trace its path. The link between them is undoubtedly one of the most thrilling frontiers in modern astronomy, compelling us to continually challenge our perception of reality. As our explorations continue, we will undoubtedly discover new perspectives on the cosmos, and quasars are certain to be central figures in this unfolding narrative. When you next look up and spot a quasar, reflect on its significance. This isn't merely a distant point of light. It's a testament to a universe brimming with enigmas, where each discovery moves us closer to solving its deepest secrets. Both dark matter and quasars are essential elements of this grand cosmic journey, and studying them helps us grasp our own position within this boundless expanse. To truly comprehend these enigmatic beacons of the universe, space missions have been absolutely essential. Since their discovery, quasars have consistently pushed astronomers to venture beyond established knowledge and explore new frontiers. The Hubble Space Telescope, launched in 1990, was one of the first revolutionary missions, delivering breathtaking images of quasars for many years. Imagine having an observatory in orbit capable of peering billions of light-years into the past, giving us a direct window into cosmic history and revealing that some quasars burn so brightly they can eclipse the very galaxies they inhabit.
Hubble, however, was not on this mission alone. In 1994, the ROSA T-X-ray satellite mission turned its focus to light emitted at wavelengths invisible to optical instruments, a critical step that showed many quasars release tremendous energy as X-rays. This discovery was vital for understanding the nature of their energy production and its connection to the supermassive black holes at their cores. Later, the Fermi Gamma Ray Space Telescope, launched in 2008, became another powerful ally, allowing us to investigate a part of the electromagnetic spectrum that had been poorly understood, and providing data that showed quasars could be far more energetic than theories had predicted.
Even missions with other primary objectives have added to our knowledge. The Kepler Space Telescope, famous for its exoplanet hunting, also contributed by monitoring fluctuations in the brightness of quasars. These variations in light can offer subtle hints about a quasar's internal structure and the dynamic processes happening near its central black hole. Complementing these observations, supercomputers create models that simulate the behavior of matter around a supermassive black hole, allowing researchers to visualize how it accelerates and heats up to generate the immense energy that defines these cosmic titans. Looking toward the future, some missions are specifically engineered to find quasars in the earliest epochs of the universe. The James Webb Space Telescope is set to continue its groundbreaking work, mapping the structure of the cosmos and studying how the first galaxies and quasars took shape over billions of years. At the same time, international collaboration has proven indispensable in this field. Telescopes from all over the globe have synchronized their efforts to observe quasars across different wavelengths simultaneously, giving scientists a much more complete and detailed picture of these fascinating objects. Every new discovery seems to generate a fresh set of questions. Each piece of information gathered about quasars helps us not only to understand these objects better, but also to comprehend the universe on a grander scale. How exactly do these powerful engines influence the formation of galaxies? What can they teach us about the overall evolution of the cosmos? Every space mission contributes another crucial detail to this intricate puzzle, gradually clarifying the vital role that quasars have played throughout cosmic history. These space missions are more than just exercises in data collection. They represent an ongoing odyssey where human curiosity directly confronts the sheer vastness of the universe. With our powerful telescopes and satellites, we have successfully managed to decipher a portion of the cosmic story woven around quasars. These objects act like celestial lighthouses, guiding us toward a more profound understanding of the fundamental nature of space and time. The exploration of the cosmos is far from over. As our technology advances, our capacity for observing quasars with greater precision also grows. With every new mission launched, we inch closer to resolving some of the deepest questions in cosmology. It is a fascinating paradox. With each new discovery, the universe becomes a little more familiar to us, yet it also reveals new layers of complexity, compelling us to continue our search for answers. Quasars are truly captivating phenomena that have stirred the imagination of both professional astronomers and amateur skygazers. But a truly spectacular question emerges. What occurs when one of these brilliant cosmic beacons gets too close to a black hole? The answer not only sparks curiosity, but also provides a glimpse into one of the most mysterious and awe-inspiring events the universe has to offer. A cosmic dance between a whirlpool of light and a supermassive black hole. This isn't merely a chance meeting in space. It's a powerful display of gravitational forces that can set off a chain reaction of cataclysmic events. When a quasar and a black hole draw near one another, a process called accretion begins, where the black hole's gravity starts siphoning matter from the quasar,
As this hot gas and dust spirals toward the black hole, it forms an intensely luminous accretion disk that radiates with incredible power, capable of outshining the combined light of billions of stars. The energy unleashed during these encounters is so colossal that it can influence an entire galaxy. For instance, the fierce radiation blasted out by a quasar can superheat the surrounding gas, which in some cases can actually halt the formation of new stars. This process is fundamental to grasping how quasars shape the evolution of the galaxies they inhabit. As a quasar steadily devours the material around it, its luminosity can fluctuate wildly. This flickering is far more than a visually stunning phenomenon. It gives astronomers critical clues about the properties of the quasar and its associated black hole. Have you ever considered how scientists track these variations and what kind of information they can deduce from them? To study these cosmic events, astronomers rely on powerful telescopes and highly sophisticated observational techniques. By carefully analyzing a quasar's light spectrum before and after an encounter with a black hole, they can determine details like the speed of the consumed material and the sheer quantity of energy being released. But what does all of this mean for our larger picture of the cosmos? Every collision between a quasar and a black hole yields invaluable data, helping scientists to better map the evolution of galaxies and the intricate dynamics of the universe. You can think of these events as open books, with each one revealing a new chapter in cosmic history. However, the story doesn't end there, as these encounters raise even more questions. Could the interaction between a quasar and a black hole actually result in the birth of new quasars? This is a fascinating possibility. When a black hole consumes a massive influx of matter, its growth can become explosive, potentially igniting a brand new quasar and suggesting a cyclical pattern of cosmic birth and destruction. As astronomers continue their explorations, advancements in technology are enabling us to witness events that were once completely hidden from view. Next-generation telescopes, for example, are engineered to capture quasar light across a wide range of wavelengths, which will provide a much fuller understanding of what unfolds during these dramatic cosmic encounters. What future discoveries await us regarding the behavior of quasars and black holes? The collision between these cosmic giants is more than just a breathtaking spectacle. It also serves as a critical key to unlocking the secrets of dark matter. Because these events eject immense amounts of energy and matter, they might provide hints about the fundamental composition of the universe and help us finally solve the puzzle of dark matter, which seems to constitute the vast majority of the cosmos. The sheer complexity of these interactions serves as a potent reminder that the universe is a place filled with endless surprises. As scientists delve deeper into the mysteries of quasars and black holes, each new discovery only opens the door to more questions and possibilities. It's exciting to think about what new theories might arise from studying these extreme phenomena. Indeed, the relationship between quasars and the even deeper enigma of dark matter is a vibrant and promising field of research. To understand this connection, you might think of the universe as a giant puzzle where you have all the pieces, but many of them are simply invisible. This is precisely the situation with dark matter. We cannot see it, yet we know it's there because of its gravitational influence on everything we can observe. Within this cosmic puzzle, you can imagine quasars as the bright glowing pieces. They act like beacons that not only illuminate the distant universe, but also provide clues about its hidden structure. Because they are so bright and so far away, quasars give us a unique method for studying dark matter, as their light must travel for billions of years across the cosmos to reach our telescopes, gathering information along its journey. As the light from a distant quasar travels through space, It can pass through the halo of dark matter that envelops a galaxy. While this dark matter emits no light of its own, its immense gravity behaves like a lens, bending and warping the path of the quasar's light. This effect, known as gravitational lensing, has become an exceptionally powerful tool for astronomers.
So, what does this phenomenon reveal about dark matter? By meticulously studying these optical distortions, scientists can map the amount and distribution of dark matter throughout the universe. You can think of it as using a treasure map, where the light from quasars provides the crucial clues that lead you to the location of this unseen cosmic fortune. This makes quasars not just objects of study in their own right, but also vital messengers, carrying information about the very fabric of the cosmos.
The profound connection between these two phenomena also leads to some compelling questions. For instance, is it possible that the presence of a quasar could be an indicator of a massive concentration of dark matter? This possibility continues to drive research, promising to deepen our understanding of these incredible cosmic components.
Certain scientists propose that when you observe a quasar, you're not just seeing the light from its central, supermassive black hole. You are also witnessing the entire cosmic environment it inhabits, which is heavily shaped by dark matter. This perspective unlocks novel theories regarding the formation and evolution of the universe. Dark matter is also a crucial ingredient in the creation of galaxies. Computer models demonstrate that without it, galaxies would lack the necessary gravitational pull to coalesce and form the stable structures we see today. Consequently, quasars, positioned at the hearts of these galaxies, serve as direct evidence of this fundamental process, acting like cosmic lighthouses that illuminate not just our view, but the very fabric of the universe and how it has been woven together through eons. The link between quasars and dark matter extends even further. A number of researchers are exploring the potential of using quasars as cosmic yardsticks to measure the expansion of the universe. By analyzing how light from quasars interacts with dark matter across different epochs, scientists can extract vital data on how the density of dark matter has shifted throughout cosmic history. Consider quasars as beacons scattered across an ocean of cosmic enigmas. As you navigate this vast expanse, they help you pinpoint the islands of dark matter and comprehend the invisible currents that flow around them. Each new observation of a quasar is like switching on a light in the profound darkness, unveiling another detail about the cosmos that envelops us. Despite significant progress in this research, a great many mysteries persist. For instance, why does dark matter appear to be so plentiful in some cosmic regions and not others? And what specific part does it play in the birth and eventual demise of quasars? Every answer we uncover seems to spawn a new set of questions, ensuring the study of quasars and dark matter remains a captivating and constantly evolving field. As our exploration of this connection deepens, we may find that quasars are more than just objects of astronomical interest. They could be the very keys to deciphering the universe's greatest puzzles. It's possible that dark matter is the fundamental thread binding all cosmic elements, and quasars are the luminous markers that guide us through this immense and intricate network. The relationship between quasars and dark matter represents one of the most exhilarating frontiers in contemporary astronomy. It compels you to reconsider your understanding of the universe and to question concepts you may have accepted as certain. As this journey of discovery continues, we will undoubtedly develop new ways of perceiving the cosmos, with quasars steadfastly remaining central figures in this ongoing narrative. So the next time you gaze upon a quasar in the night sky, take a moment to reflect on what it truly signifies. It is far more than a simple point of light from a distant past. It stands as a profound reminder that the universe is teeming with mysteries, and every new finding inches us closer
to unraveling its deepest secrets. Quasars act as cosmic lighthouses, casting their light across the immense ocean of the universe. Yet many questions still remain in the shadows. For example, astronomers are actively investigating how these powerful objects influenced the formation of galaxies when the cosmos was in its infancy. By examining the intense radiation from quasars, we can develop a clearer picture of galactic development and the overall evolution of the universe over billions of years.
Our technology is advancing at a breathtaking pace, transforming the methods we use to observe these cosmic spectacles. Next-generation instruments, including the James Webb Space Telescope, give researchers the power to gaze further back in time than was ever previously possible. Each new observation offers a precious glimpse into the past, showing us quasars as they existed when the universe was still young. Almost like having a time machine to witness the assembly of the matter around us. However, gathering the data is only half the battle. Its interpretation is equally critical. By carefully analyzing the spectrum of light from a quasar, for example, scientists can deduce the elemental composition of its immediate surroundings. This light holds the potential to reveal profound secrets about how the universe's elements were forged and distributed, offering clues to the history of our very own Milky Way galaxy. Furthermore, quasars present a fertile ground for testing theories related to dark matter and dark energy, two of the most persistent mysteries in physics. Could these luminous objects finally unlock the secrets of dark matter's role in shaping the large-scale structure of the universe? As scientists delve into these questions, they may uncover unforeseen connections that revolutionize our entire conception of the cosmos. Finally, the importance of global cooperation in this field cannot be overstated. Astronomers from all corners of the world collaborate, sharing their data and observations to construct a more comprehensive understanding. This synergy, born from combining diverse perspectives and intellectual traditions, can spark discoveries that a single research group might never achieve on its own. Science is fundamentally a collective human endeavor, and the study of quasars provides a perfect stage for this powerful collaboration to flourish. The incredible lights of the cosmos, known as quasars, have revealed a vast amount about the fabric of our universe. As immensely powerful energy sources situated billions of light-years away, they don't just brighten our view of the night, they also illuminate our grasp of space's past and its future. On this fascinating expedition, you will explore how quasars function as beacons in cosmic darkness, unveiling secrets that would otherwise stay concealed. When you gaze into the sky, you might ask yourself why quasars hold such importance. The significance is found in their capacity to narrate the story of the cosmos. You can think of every quasar as a sort of time capsule, transmitting its light across the immense emptiness of space. This light serves as an echo from eras when the universe was young and tumultuous, offering us a window into how the earliest galaxies took shape and how our own cosmic neighborhood evolved. The immense energy they radiate is still largely an enigma. We understand that supermassive black holes power quasars, yet the specific dynamics that result in their formation and intense brightness are incredibly complex. What allows a quasar to be so potent? They produce energy at a staggering pace, with matter spiraling into the central black hole and erupting into a blast of light and radiation. This entire process unfolds like a cosmic ballet, where chaos is transformed into observable light. In our pursuit of knowledge, quasars also advance our comprehension of the universe's structure. If you've ever wondered about the mechanics of galaxy formation, you should know that quasars are pivotal to this process, serving as catalysts that shape their local environments.
By unleashing colossal amounts of energy, they can influence the birth of new stars and the progression of galactic matter, which is fundamental to understanding how the cosmic tapestry you see today was woven.
When discussing quasars, it's impossible to overlook their relationship with black holes, as these invisible behemoths are central to the quasar narrative. Every single quasar is located at the heart of a galaxy, which is precisely where a supermassive black hole is found. Their connection reads like an epoch of power and brilliance, in which the black hole acts as the engine for the quasar, and the quasar, in return, lights up the universe, reminding you of the deep interconnectedness of all cosmic components. As we look toward the future, we must consider how artificial intelligence will affect the analysis of quasar data. The sheer volume of information being generated is enormous, and AI could become essential for spotting subtle patterns and anomalies. Could artificial intelligence even guide you to discover quasars that have so far eluded observation? The synergy between astrophysics and sophisticated technology holds the promise of revolutionizing our cosmic understanding. Education and public outreach are also indispensable parts of this journey. It's crucial that we convey our findings to the general public in an effective manner to keep interest in astronomy alive. So how can you help inspire the next generation to continue investigating the mysteries of space? By crafting compelling narratives about quasars and their universal impact, we can encourage young scientists to embark on this thrilling quest for knowledge.
Furthermore, research into quasars carries implications for the search for life beyond our planet. If these cosmic objects guide the formation of galaxies, could they also foster conditions favorable for life to begin? This potential link between quasars and the possibility of life encourages you to reflect on our own place in the universe and the fundamental nature of existence.
You should also remember that quasars can signal broader cosmic phenomena, such as the expansion of the universe. The manner in which they interact with other astronomical bodies can offer clues about the properties of dark energy. It's entirely possible that these celestial beacons are the keys to deciphering how the universe operates on the grandest scales, making the search for answers both exhilarating and essential. As you and I advance into a new age of discovery, it is vital to keep curiosity and imagination at the forefront. While quasars represent just one fragment of the universe's immense puzzle, their study propels us to venture even further. What incredible wonders are waiting for us just over the horizon? The investigation of quasars is far from complete, as each new generation of telescopes and every technological breakthrough brings us nearer to unlocking the secrets the universe holds. In the end, the future of quasar research is luminous and filled with immense potential. There are countless questions that still await answers, and every new discovery draws you closer to comprehending our own existence within the context of the universe as a whole. The study of these cosmic lighthouses not only illuminates our past, but also acts as a guide into the future. The grand adventure is truly just getting started. When you consider the significance of quasars, it's essential to see each one as a living record of cosmic history. They grant you a direct view into the distant past, showing not only how galaxies evolved, but also how the universe itself has transformed over eons. This raises the question of just how far your understanding of these luminous objects can ultimately extend, and what profound truths they might eventually reveal. In the journey to unlock their secrets, you may uncover fundamental details about the very nature of space and time. Quasars are so much more than mere specks of light. They are brilliant beacons that illuminate the path toward comprehending the cosmos, unveiling its mysteries, and pushing the limits of your imagination. As the exploration presses on,
Every discovery brings you closer to unraveling the universe's greatest enigmas, confirming that this incredible adventure is only just beginning.